Hello, this is Master. Welcome to Learn with Master. The question you're seeing on the board right now is a question right from 2003 JAM Mathematics Past Question, question number 9. Make sure you share the video, make sure you like, make sure you enroll. If 9 raised to the power 2x minus 1 divided by 27 raised to the power x plus 1 equals to 1, find the value of x. You can pause the video and try this out by yourself just to check if you can get the correct answer. Let's begin. The first thing we'll do is that we'll express 9 in the simplest possible base, express 27 in the simplest possible base, and the base which we express, the numerator and the denominator, will determine the base in which we are going to express 1, which is the right hand side. The simplest possible base which we can express 9 is 3 raised to the power 2x minus 1, 27, 3 raised to the power 3 into x plus 1. And on the strength of this basis, 1 will be expressed with a base of 3. The only way we can express 1 with a base of 3 is by saying 3 raised to the power 0. Because any number raised to the power 0 is 1. Moving forward from there, in the law of product, in the product rule of indices, this 2 is multiplying everything outside that bracket. So this will be 3 raised to the power 2 into 2x minus 1 all over 3 raised to the power 3 into x plus 1 equals to 3 raised to the power 0. Moving forward from there, the numerator is having the same base and the denominator is having the same base. In one of our rules of indices, we say that x raised to the power n divided by x raised to the power n is equals to x raised to the power n minus n. So we subtract the powers. Meanwhile, this can also be written as, x raised to the power n divided by x raised to the power n. Yes. So that I mean. So we can apply that same rule here, and when we apply that same rule, you will see that this is 3 raised to the power 2 into 2x minus 1, alright, minus the power here is 3 into x plus 1 equals to 3 raised to the power 0. Meanwhile, you can decide to expand this first. You can decide to expand this first before you apply that rule. It's still going to help to give you the same answer. We move. So I've applied the rule, now I want to expand. You can decide to expand first before you apply the rule. We continue. Opening the bracket, this gives me 3 raised to the power 2 times 2x is 4x, 2 times minus 1 is minus 2, minus 3 times x is minus 3x, minus 3 times plus 1 is minus 3 equals to 3 raised to the power 0. From there, we can see that the base in the left hand side is the same as the base in the right hand side. So the basis is going to cancel. The powers will drop. Another student can decide to simplify the power, the expression in the power, before cancelling that base. Whichever way still gives you the correct answer. So the power dropping becomes 4x minus 2 minus 3x minus 3 equals to 0. I will collect like terms. When I collect like terms, what I now have is I'm going to group x and I'm going to group the terms without x together. So what I have is 4x minus 3 minus 2 minus 3x rather minus 3 equals to 0. 4x minus 3x is 1x. Minus 2 minus 3 is minus 5 equals to 0. If you look at this critically, see, 1x is the same thing as x minus 5 equals to 0. We are almost there. Collecting like terms, I am going to shift the terms without x to the right hand side. So this is 0 plus 5. So you can see with me that x is equals to 5. And that is our answer. This this was a very cheap question. It looked complex, but there's nothing really there. Alright? This is to tell you that we have arrived at this interesting journey. And I'm telling you right now that more questions like this will be solved in our exam revision classes. We're starting 1st of December. Make sure you enroll. Make sure you share this to a parent, because your journey to mastery begins here. We begin from 1st of December 2025, and we're going to take the journey till April 30th, 2026. Start early, register early. See you in our exam revision classes. God bless you. Your journey to mastery, it begins here. It begins here. Bye-bye.